Okay, so here is another problem for review, and here's a curved beam problem. And it's a utility hook. It's formed from a round rod of 20 millimeters diameter, and in the geometry shown there below. What are the stresses in the inner and outer surfaces at section AA, right there, if the force is 4 kilonewtons, the length right there is 250 millimeters, and the DI, as shown, is 75 millimeters. And I think this is problem 3120 from one of the editions. Let's see, 3120. Let's see, is that 3120? There it is, 3120. Woohoo! So let's look up. Let's go to the curved beam stuff, just since we're on that subject, and it's circular. So here are the equations that we're going to need to use to find the center of the centroidal center, and here's the neutral axis for the thing. So let's move on. Why do I have these lines across the thing? I don't understand. I don't understand why that happens. Is it this light? See, if you turn this light off right here, all of a sudden it's very dark for me, but we don't have those lines anymore. It's a little too dark to work because I have this terrible light bulb. This thing, this light over here, it's just terrible. See, it's just barely any light going on. So I have this other light. Whee! That's very bright, and it does weird things like those horizontal lines. It's like a hamburglar is out to get us or something. I don't know. So anyway, let's just continue on here. All right. So if we're going to try to match up with things that are I'm going to say D is equal to 20 millimeters, right? So that's going to be to match up with the equations that are in our book. And I want to get the area, the cross-sectional area for that. So that's pi over 4, 0.02 squared, or 3.1416 e minus 4 meters squared. Okay. And I think I'm at the end of my lead, so I have to get my leads going in and get the lead out. There you go. There's a little bit of lead. Put him on the floor, never to be vacuumed up. Okay, so the inside radius here is going to be that big DI that they gave us over 2, and they gave us the DI was 75 millimeters, so it's 37.5 millimeters. And the RO, so that's to the outside of this, RO is just going to be RI plus the D, or 20 plus that. So we have 57.5 millimeters. And from table 3.4, if we use capital R is D over 2, or 10 millimeters. Right? That's making sure that if we look in table 3.4, that's the radius of the circle that makes up the thing. We see that we have an RC equal to RI plus capital R, or 37.5 plus 10, 47.5. millimeters. If we have Rn, this is capital R squared divided by 2 times the quantity. I don't like what I have written down. One second. Let me go to here. The quantity RC minus the square root of RC squared minus capital R squared. Close parentheses. So on my page, I have it written wrong. Yeah, okay. No problem. Just making sure. Just making sure, man. Don't call me man. So we got 10 squared divided by 2 times RC of 47.5 minus, yeah, so all of this inside the square root better be smaller. 47.5 squared minus 10 squared. Close there, okay. And I get this one to be 46, and we want a lot of siggy figs. 46.96772 millimeters. So when we get to E, that's RC minus RN. And this one better be less than that one. Well, you can see I have 47.5 minus 46.96772. And you get 0.53228. So I guess I'd stuck with 5 sig figs there. That's a lot of sig figs. CI is RN minus RI. That's the inner thing. So that's the 46.96772. This is ridiculous. 37.5, and we get 9.4677 millimeters. And then if we get the CO, RO minus RN, or 57.5 minus 46.96772. That's a lot of siggy figs. 10.5323 millimeters. You don't need that many. You only need 4 sig figs in each of these things, and you'll be fine. So if we're going to have the inner stress, is going to be F over A plus M. We need to calculate M. CI over AERI. So for and this is a simple one here, pretty simple thing to do. So here's our FBD right there, right? Because we're taking a cut right in here. We want to see the internal loads that are happening onto the thing. All right, here is our force of what? 4 kilonewtons, 4,000 newtons happening right here. So we have a reaction, that's right in there, and we have a moment. This one wants to go clockwise, so this one better want to go counterclockwise. So here's your M, and we'll say that it's an MA. This is RA right in there. So we do the sum of the moments about the center of that thing, about the center of the cross section up there. I just marked it, you couldn't see it. So MA, and it's going to be minus our 4,000, and the distance from here to here is the RC right there, right? So I should have kept this as kilonewtons and this is millimeters, so they could have canceled each other out, but I already wrote it down. 475 right there equals 0. So we got MA is going to be 190 Newton meters is what that turns out to be. So we can go ahead and plug this thing in here. The force is 4,000. The area we calculated the top of 3.1416 E minus 4. And that's, yes, that is going to be tension, and the inner one is also good. This is going to, inner is going to be tension, and this is going to cause tension to be positive and positive, right? And as a little in between step, we note that that's 12.73 megapascals in tension, and this is 190. CI is, now we want to make this into meters, so 9.468 E minus 3 meters, and that area again 3.1416 E minus 4. E, I think instead of drawing a bunch of zeros in there, I'm going to write 0.53228 E minus 3. Look how I cheated. And then RI, which is somewhere at the top, is 37.5. So 37.5 E minus 3. I cheated it there too again. And this was 286.7 megapascals. So I can find my inner is going to be 299.6. Should just call it 300 in its intention. Boom. And then with the outer, F over A minus MCO AERO. And we know this is going to be 12.73, right? Megapascals. Minus 190, and that CO was 10, so I'm cheating again. 10.53. We don't need to go any more sig figs than that. 3.142 E minus 4, and the E is the same 0.532, right? 2, 3, yep. E minus 3, and then RO is at the top of 57.5, so 57.5 E minus 3. And what is that happiness? 208.12 megapascals. So we answer that, put those together, and we end up with 195.4 megapascals compression. That's just running through the motions. It's maybe the problem's too easy. It's because it's just I don't know, just a basic problem, just a plug and chug. Can you navigate your way through this? But it's another practice problem. You should try it out before you try out some more problems. Then pick out a problem out of the book. See, I'll give you the answer to it. So try that out. Idea.